Alright, we're going to begin to develop the architecture of a songline processor. And I'm going to work with four-sided cells. Eventually we're going to move to actually three-sided, but to keep us closer to the cell matrix, let's start with just squares. And these are going to be connected to their nearest neighbors in the way that we're used to. And we're only going to talk about D mode for now. We'll introduce C mode in a few videos, but for now let's just think about passing data from cells to cells. So we have communication going in this other direction as well. And again, let's imagine these are just D lines passing data. So this is cell 0, 0, this is 1, 0, 0, 1, 1, 0, and 1, 1. All right. We need to define a function inside each of these, and we're going to do it mostly just with plain old mathematical notation. So suppose we want to build a multiplier, an amplifier, something that takes an input here, amplifies it, and produces an output here. So we could have some input here, x, and we could have some output out. Let me call this in. And we could define a function in here as follows. So let me call this function 0, 0 north. And that's just equal to 1,000 times west. So whatever value comes in on the west gets multiplied by 1,000 and goes out to the north. And we may need to do some clipping. So this might be the case where west is less than or equal to 0.001, and the output might just be 1 if west is bigger than 0.001. So the output of this amplifier is guaranteed to never exceed 1 volt, but if you put in a value somewhere below a millivolt, it'll get scaled up by 1,000, and the corresponding voltage comes out on the north here. So that's a simple amplifier. If you want a variable gain control, we could have a gain input here, and we could take this input and map it to the north so that it comes into the south of this. And now we can modify this function and say this is, let's say, the western input times the southern input, and let's multiply it by an additional 200. So now our gain is going to go anywhere from 0 to 5 volts. If our gain is 0, then the southern input here is 0, and the output will just be 0. But our gain can go up to, say, 2.5 volts, in which case we have 2.5 volts on the south. We have some input, and this is going to be 2.5 times 2 is 500 times W. This is a 500x multiplier. And if we turn the gain all the way up to 5 volts, we have 5 volts on the south, we have some input here, and the output to the north is 1,000 times W, so our output can go up to 1,000x, 1 volt, as a peak. So this is a variable gain amplifier. You can turn this gain from 0 up to 5 volts, and this will go anywhere from a flat output to 1,000 times your input. And again, it clips the output at 1. So how do we define this wire? That's a very simple function. So F10 north is just equal to west. And certainly if we can store functions that correspond to multiplication, we can store functions that are really just the identity element. And the functions here and here don't make any difference. All right, so that's a view of a four-sided songline processor. Let me get rid of the arrows showing the connections. We'll just understand that things are connected to nearest neighbors. And let's look at a few other things that we can do. Suppose we have a cell here, and we have some signal coming in, which again I'll call input. And we have the following setup.